Hi everyone and welcome back. In the final section of this course, you're going to learn how to build and distribute your Go application. In this video, we're going to start off with dependency management using Go modules. As soon as you use any Go package that is not part of the Go standard library in your program, you have a dependency on that package. Anyone who wants to build your software by themselves will need to have all dependencies of your program present on their local system. Originally, this was accomplished using the Go path. You install packages in your Go path using the go-get command. However, you typically have no control over which version of a package is going to be installed. Typically, go-get will always install the master branch of a dependency. Because of that, you cannot have a reproducible build, since each time you run go-get for a given package, a different, newer version might be installed than the last time. Also, you can only have one version of a package installed on your machine at the same time. In previous versions of Go, this was solved by vendoring. This describes an approach in which you copy dependencies of your package into a directory named vendor inside your own package. To make this process of copying dependencies easier to handle, there are multiple tools like, for example, dep, glide or godep that automate this process for you. This allows different packages to use different versions of a dependency, but still requires you to set up a central Go path directory on your machine. Go modules is an even newer approach to handling dependencies in Go. Experimental support for Go modules has been introduced in Go 1.11, which is incidentally also the most current version at the time that I'm recording this course. Go modules allow you to require specific versions of dependencies in your software, and, more importantly, do not require a correctly set up Go path. To use Go modules for dependency management, you first need to create a Go module for your package. To do that, run the go mod init command in your package directory. That directory should not be within your Go path. Let's have a look at how that works in action. This is an entirely empty directory that's not placed in my Go path. So let's start by making this directory a Go module. This command creates a file, go.mod, which initially only contains our module name. Later, this file will contain all dependencies of our module. Let's continue by adding a short Go file that uses a third-party library. In this case, we are using the logrus library, which is not really complicated, it's just used for logging. So let's see what happens when we compile that program. When we compile that program, Go build automatically identifies all third-party libraries that are used by our software and downloads them automatically. All dependencies are automatically added to the go.mod file if they're not already defined. Here you can see that the logrus library is now required in our go.mod file, and also that a specific version of that library is required. So if you would to check out, if you would clone this repository and run go build again, go build would also download that exact same version of that library again. You can also notice that a second file go.sum is being created. This file contains checksums of all modules that have been downloaded. Usually you should check both of these files into version control. The go mod command has some other subcommands that might be useful. For example, go mod tidy can be used to remove dependencies from your go mod file that are not actually used in your code anymore. And if for any reason you need an old school style vendor directory, you can create that by using the go mod vendor command. Go modules are the intended new default way for handling dependencies across projects. In upcoming versions of Go, module support will be extended and more deeply integrated into the toolchain.